This is basically set of rule which will allow or deny the specific traffic which you want. Specific traffic or your interesting traffic or your interesting traffic. Moving through the router means which you can allow or deny traffic according to your need. This is a kind of basic security on router. Basic security. Router also work as a security device, but very basic. Sometimes we say it is packet filtering firewall. For access list, we say packet filtering firewall. Always remember on for security we have different device firewall, but your router can also provide basic security. Suppose that if I have a small network, 2, 3 routers there, very small network, so I can suppose that I have 2, 3 routers. I don't need firewall. Suppose that I don't have budget to buy a firewall because firewall sometimes is very costly. Not sometime, every time it's costly. And I know I can use my router as a firewall also. So in that condition, I can use ACL, access control list, or you can access list, access control list. But if you are going for interview, so don't say access control list, just say ACL. Because what I have seen, lot of the time, Indian takes your interview. If you are going to interview, almost 80% time you will see Indian will take your interview. So they pronounce, ACL or access list. Okay. So basically it's suppose that A and this is B and this is C. I have some traffic on C. I have some network on C and I don't want to allow it will come to B. So I can stop this traffic for some time or for always. Basically, I will stop my traffic one router to another router, or I will permit my traffic. I will show you how you will permit, how you will stop your traffic. I think you got it. Basic thing of access let what it does. Just it allow,
So, Ashish,
yeah.
does this access list different from the one that you're going to determine the total number of total number of IP you want on your that you need to allow?
No, it is
Like
all
total
same.
number of device you want to allow, is this different from the access list or is the same?
It is same. You can
Oh,
allow your total number of traffic, or you can deny your total number of traffic.
Yeah, because the reason I'm asking, because you are using router for example here, so like the one we did in that project,
Yeah,
one that we have to
there was a
now add,
switch, L3
yeah,
switch.
yeah, switch, yeah, yeah, in the switch whereby we allow the total number of what were we were adding something, adding a server on IP server, something like that.
Yeah, we permitted related to uh SNMP
SNMP, okay.
and
So I mean, so in this one too, one can it can determine the number of IP or device you want and the one you don't want to allow, so that just anyhow device will not be able to, just trying to think based on what we did in the switches, whereby we have numbers of switch and no any other device can just go in except to allow them on the access.
yeah, 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 right, right. Basically, just remember your interesting traffic, what you want to allow and what you don't want to allow. It's just so in that condition we allowed SNMP and ping request for a specific like devices. Suppose that it is a router or layer 3 in sometime what happen if company has good budget, so they don't use router, they use layer 3 switch or multi-layer switch. Multi-layer switch can perform L2 and L3 both function, means router and switching both function. So this kind of switch, suppose that there is a user, this user is 172.18.20.1, suppose that, right? This user, this is outside user, and this is my, you can multi-layer switch or L3 switch or router, whatever. Okay, no problem. Only L2 switches we cannot do this thing. Only L2 switches. We cannot make access list. We cannot make. So this user wants to communicate inside. Yes.
Sorry to cut you. I just want you said something that so layer two and layer three switch can perform both switch and router, right?
No, no, no. Only see. We have three category of switch.
Okay.
First
Yeah.
is access layer switches. This kind of switch just they can perform only L2,
Okay.
only L2 level task. L2 level task means data link layer. Data link layer means it can work only on MAC address, and it's very like you can say low budget switches. Okay, just you have to do, just it will work on MAC address.
MAC address. Okay.
Yeah,
So, but for a novice like somebody like me, how are you gonna know uh L2 switch and L2 and 3 switch? How will I know? There's a command to check that.
yeah. First you can confirm about by series what is
Okay.
L2 switch and L3. Second thing, basically what we do, you can use show IP route option. If
Okay.
it is doing routing, so basically it is not L2 switch, because
Okay.
I already said L2 switch cannot perform routing.
Yeah.
It works only, it cannot perform routing. It only works on MAC address. So you can check by series also. Lower series, you will always get L2 switch. Higher series, you will always get that is layer 3 or multi-layer switch. So one more thing here, distribution layer. This is a hierarchy. So in distribution layer switch, I think we have category also. Let me see. Maybe I forget about name. So we can check. I will show you. We can check. We can check access layer switches series. So it will show you campus LAN catalyst. Mhm. No, this is not campus LAN. No, no, no. Yeah, this is a good diagram. Let me check. Can I have more documents so I can show you better way? Oh my god, it's very small. No, no, it's not good. They didn't give any good diagram there. I think it is better. Yeah, it's better. Okay, so this is layer 2 switch. So they are asking a question like suppose that is my domain is pure layer 2? So yes, layer 2 switch only work on layer 2. Layer 2 means only it will work on MAC address.
Okay.
Purely MAC address. Just it's kind of there is something port, okay?
Okay.
Just you have to put your PC or your devices on the port and it will start working. Basically, here router will do perform work. According to router, it will perform work. Layer 2.
Okay.
This is a multi-layer switch. It can perform both L2 and L3 task. L2, L3 task means MAC address plus IP address.
So it can perform every of the task.
Yes, every task, whatever you can do on router or whatever,
On multi-layer.
yeah, multi-layer. But there is a problem.
Okay.
What is the problem? This is a combination of two devices, okay? Router and switch, right?
Mm.
You have one device and you are performing both things there. So your device will take, too much memory
Oh,
and
okay.
it will too much heat. Heating issue will become.
Mm. Mm.
So basically, we avoid all the things on multi-layer switch. We just, basic kind of routing we do there. Basic kind of routing. Basic kind
Yeah.
of your uh, suppose that basic kind of your router. Suppose that router is a pure routing device. Okay, it will communicate only like router to router and different network. It will communicate in different network. Multi-layer switch also can perform communication in different network. But there is a limitation, cost also limitation. Multi-layer switch is very costly according to router.
Mm.
Okay. If I have suppose that I have only routing task, so why I will buy multi-layer switch? Because it's very costly. You can check multi-layer switch costly than router sometime. Not sometime, always.
So, but some people, most company buy the multi-layer switch and just
Yeah,
use it or just switch alone.
yeah. It's right. Because they do basic routing also there. They does basic routing also, multi-layer switches. But you will not find any function like router there. Like it is performing your WAN area also. It is performing your uh, traffic filtering. Traffic filtering means your interesting traffic. That's it. Sometimes people get confused of this word, what is traffic filtering? Just your interesting traffic. Or your net option. That means your IP network address translation means your private to public IP conversation.
One more question, Ashish.
Yeah.
Can you run, for example, if this multi-layer switch is Cisco and the router is Cisco, can you run the same command to checks if you want to? Is it possible, or they have different command to, if I want to check something on it?
Yes, Cisco has same command.
Okay, same command. Okay.
Same command. You know, there is only one difference in Cisco and other like Juniper. There is a main basic difference.
Mm.
What Cisco does? Okay, let me complete this.
Yeah, okay, I'm good now. Sorry.
Yeah. So you will find just like 2600 series here. You will find like this 2600 series switches or 2900 series switches. Some series I know, I'm just telling you. On access layer switches. Distribution layer switches, you will get like it can perform. It's very, you cannot say it's very high or it's a kind of medium switches like medium range switch. Medium range switch means it can perform routing and switching both. Routing and switching. But cost is not too much high. And not all routing option. Some routing option. Some routing option and other switching option. Suppose that 70% switching plus 30% routing, right?
Mhm.
Here you will find 100% switching. Then I have core layer. This is very heavy switches, core layer. You can understand by name, core layer switches. In distribution layer, you have 33750, this series, Catalyst 3750 and 36600 series or 3700 series. This series will cover in distribution layer. But core layer, this is very heavy switches. Heavy means not about weight, about processor and memory. Basically, you will find in the, we will see this kind of switches. When you are getting a link from the ISP, or you can simply write here data center. In data center, simply write there data center. I'm just making your work, easy to understand. Core layer you will find in data center. What happens? Suppose that this is my core layer switch, means it is in core layer. Here I have one more core layer switch. So basically what happens, suppose that this is your ISP, internet service provider, and this is your MPLS. Just forget about MPLS for some time. Okay, you are one you are getting one link from ISP and one link from MPLS. This is switch 1 or switch 2. Same here, you are getting one link from ISP and one link from MPLS. So you will find, when you will see, you will find like this topology in real time also. They directly deal with your internet service provider or layer switch. In data center you will find, and basically in core layer you will find Cisco Nexus 9000. If you are using Cisco, so you will see Nexus series there. Nexus is little different, not little, it is different from normal Cisco switches. It can perform more tasks. Okay, so basically it will deal directly to your internet service provider. This kind of switches, core layer switches. Okay, so my topic was access list. You can read about it little bit. I gave you idea. Interest, please won't be the class tonight. Okay. Okay. So where we were, sorry. Access list we have two types. First one is standard. And second one I have extended access list. Now, why two types? Access list has why two types? Because in standard we have less feature. If I will apply standard access list, I have less feature. It will block my all network. There is, I have lot of stability and lot of features. This was a basic difference. Now let's see the difference. Standard access list and extended. So standard, access list, if I say about access list, so I have a range. So this access list range is 1 to 99. Range means just I will give a number to my access list, nothing else. And its range is 100 to 199. This is the range of access list. Range is when I will make a access list, so I will give a number there. So this number will define which access list I am using. If suppose that any access list I am using, suppose that access list 10. So I will understand, okay, that is standard access list because it is between 1 to 99, right? If I am using any number between 100 to 199, so I can easily understand, okay, that is my extended access list. So this number is an identification of your access list. This is basic, okay? When I will go in advance, there is more option, name, access list, other thing. But this is a basic. Your number is your number is identification of your access list. Okay. So this kind of access list, if you are applying a standard access list on your router, so it can block your whole network. It can block host and subnet. But sometimes it's very, issue. Block or allow. You can write permit, deny or permit also. It is not a problem. Both are same word. So a standard access list can block or allow your network, your host and subnet. But extended access list, you can block specific services. Services means like suppose that I want to block only HTTPS traffic. So I can block. I can block only SNMP traffic. I want to block only SNMP traffic. So I can block only SNMP, but it will not affect to my whole network. But here in standard access list, if I apply this thing, it will block everything. Network means everything. Services also. But in extended, we have option. We can block only services. Okay. We can allow and block only services. This is the option. That's why we use extended. Because suppose that one user doesn't want to, I have one user. How should I? Let me show you extended and example. Suppose the standard access list. So I want to block this user. Okay. I want to block this user. Oh, 16.1.1. This is a user. I don't want uh, this will this network will come to my router. If I am using standard access list, so it will block this host and all services. Means it would be completely unreachable. So that is the problem in standard access list. I blocked everything of this user. So that's why they improved in standard access list. They make extended. So now I can choose same user. This is router, same user. I don't want this user can, I don't want this user will use HTTP service, HTTP or HTTPS service. So I will block only HTTPS traffic, not whole network. So it will affect only HTTPS, not whole network. Ping will work, SSH will work, your other services will work, but only HTTPS will not work. So that is the beauty of extended.
Mm.
Standard, your network will block completely, no services, unreachable. But extended, you can specific service. You can block specific service like ping, not ping, sorry, ping is not service, ICMP. ICMP is a protocol. ICMP has a part, echo request and echo reply. This thing we say ping actually. Basically, ping is just a command, but behind the protocol is ICMP. And ICMP has a two messages, echo request and echo reply. Echo request is normal message. Suppose that there is a two PC, 1 and 2. So PC1 will send a echo request. Just are you there? It will reply. Yeah, I am here. Echo reply. That thing we say ping. Okay. And this data carry. Always remember in networking, if you are doing anything, like suppose that you are sending data. So your data cannot go without any protocol. Uh, if you your protocol will carry your data. So ICMP carry this kind of data. ICMP is a protocol which carry this kind of data, echo request and echo reply. So suppose that echo request, okay, I sent, I use, let me go again to this thing. This is my PC1 and this is my PC2. So this is the IP 1.2 and this is here IP. I use ping, I use command a ping, okay. I'm just talking about very basic thing. 192.168.1.2 and enter. I use enter. So what happened? PC1 will send a echo request to PC2. If if PC2 is online, okay, so it will reply. Suppose that it was first packet, so it will reply echo reply 1. So according to that, like according to your machine, it will send packets. Like Cisco send packets, 5 packets. Your Windows send 4 packets. So it will send like 5 packet, 2 echo request, then it will send echo reply 2 like this. So that like that your ping function work. If suppose that this machine is unreachable, okay, one more scenario. This machine is reachable. Sorry, what I was saying. I know this machine is not reachable. 192.168.1.2. I here open command prompt CMD and I use ping command 192.168.1.2 and enter. So it will send echo request. Echo request 1, 2, 3, 4, but it is not replying. So it will show here unreachable. 0% success rate. Actually, that is the process. There is one more protocol works. ARP, Address Resolution Protocol. Did you get this thing? How ping work? Hello?
No.
Did you get this thing? How ping is working? Or any doubt?
Uh, I'm still trying.
Okay, great. No problem.
Yeah. But I might have to get it before I sleep.
Okay. No problem. I am opening my command prompt, right? I am trying to ping any IP. 192, not 192. I will ping Google IP. So first I will convert Google address in IP. So ns lookup command will convert name to IP. www.google.com. Okay. So I got my IP, my Google IP. Okay. I will ping this IP. So see, you are getting a message here, reply from this IP address. Reply from 1, 2, 3, 4 packet. Can you see these 4 packets? Let me know first. Can you see these 4 packets? It's
Mhm.
coming by from this IP address.
Yeah.
So let me make scenario here. So you will understand better. I will not go in ARP and other thing, otherwise you will confuse. Just this thing. So this is my PC, okay? My laptop or my PC. I open CMD, right? In my laptop, I use ping command, and what is the IP? 142.250.194.4,
That's
right?
yeah.
This IP I ping. So suppose that it is a server here. This is a Google server. And what is the IP of this server? This one. 142.2. Don't see there. Just see here. Okay. Right side. 194.4. Uh, just let me know. Can you understand this thing? Or you have any doubt here? Can you understand this thing?
Yes.
If you have doubt,
Yes.
ask me. I am trying to see from my laptop or my PC, this server is reachable or not. Okay.
Yes.
So internally, what will happen? I use this command in CMD ping. Okay. So my PC, just a basic scenario, it will send a echo request. Actually, it will send my router, but just try to understand. My PC will send a echo request. Are you there to this server? Are you there? If server is reachable, it will reply me. Echo reply. Yes, I am here. So same thing is happening here. Reply from this server. Just try to correlate this thing and this thing. Just leave this thing right now. Leave this thing. Just see this option. Reply from this server. So my PC sent 4 packets like this. Echo request. Are you there? This was 1. This was 2. Okay. He sent again echo reply. And number is 2. Yes, I am reachable. So see, my PC sent 4 packet, and I got reply 4 packet. That means 0% loss. Can you able to understand now this thing? What doubt you
Yes.
have? What doubt you have? Ask me if you have doubt. What doubt you have?
No, it's clear. For
Okay.
me, it's clear how thing works.
Yeah. So it's just basic about how your ping is working.
Yeah.
Just you are sending 4 packets. 4 packets, sorry. 1, 2, 3, and 4. And you will get reply from that device. Yes, I am here. 2, I am here. 3, I am here. Reply. 4, I am here. So same thing it's happening here. I sent 4 packet. When I use ping, automatically my ICMP protocol start working, and it sent 4 packets. 4 packets. 4 packets. It sent 4 packets, and he got reply. It's clearly shows here reply from that server, reply from this IP, reply from that server IP, whatever. So you are getting reply from this Google server. Yes, it is reachable. This time is show how much millisecond it takes process to reply. Suppose that I am sending you anything, like I sent you courier, and I got a delivery report. So how much time taken by this process? That is this thing, millisecond. TTL means time to leave. Time to leave means how many hops it used. How many hop it used. Hop means how many device. It means one device was there to perform this task. Two device in the middle. TTL means time to leave. Uh, I will explain you TTL in more better way. TTL means suppose that I have a 3 router or 4 router. So my TTL value is suppose that 2. So my packet will start, this is 0, 1 and 2. So my packet will go here on router 2, and my packet will drop on router 2. Oh sorry, router 3, because TTL value will end here. It will not go there on router 4. So TTL value, it's just your hop count. How much hop, like how many you are sending a packet, so how many hop it will go. Just that's it. If you have TTL value 111, so it will show you can send packet to 111 devices. If there is 1112 device, so automatically it will drop in 112. Okay, this is basically this is a IP packet format. I will explain you if I get time. Okay, let's go in the topic. Otherwise, I will forget. So basically, you got it. Basic ping, right? There was a reply and request. I send to message and you reply me. Yes, I am here. That is the ping basically. Okay, I think we were discussing about okay, difference. Sorry.
Mm.
So standard access list and extended. Extended I am writing in shortcut. So basically here your all services are blocked. I already explained this point. All services will block. Services means like your IP traffic, your TCP traffic, or your UDP traffic, all kind of traffic. It will block. Or your like HTTPS is a part of that traffic. I sent you one book. Yeah, right?
Yes.
Yeah, let me show you. Standard access list and extended access list. You can see on that book also. That is very good
Mm.
book for basic.
Yeah.
Uh, list and tuple. Static. What I was access list. Yeah. So I hope I will get that diagram which I wanted to show you. Um, mm, 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 mm. That is not okay. I will when it will come. I will tell you. It's not clear here. Not clearly defined this thing. Okay, yeah, they did not clearly define their protocol and anything. So you will more confused if I will tell you here. And in access extended access list, selected service can block. Selected service we can block. Okay. This will you will implement this access list you will implement near to your destination. Implement closest or near to your destination.
You mean extended?
Yeah, standard.
Oh, standard?
Yeah,
Oh, okay.
always have to remember you have to use this ACL near to your destination.
Mm. Okay.
Always remember near to destination. And it can you can use both side, destination or source. Basically, we use near to source, but you
Mm.
can use both side, source and destination, because extended we don't have any limitation. So in the lab time, we will see how it is work. Right now, it will little bit confusing, I know, but lab time it will be clear. One more thing I want to tell you. Yeah, okay, let just one. There is a switch. Okay, switch work on MAC addresses, right? And this router will work on IP address, right? So, can you tell me? You didn't ask me this question. That's why I'm very curious to know. And there is a PC also, and this PC also has some IP address. Okay. So how my PC, how this device is understanding about this IP address? You didn't ask me this question. Means switch work on MAC address, right? This is IP address. But how my switch know or my router know which IP has that MAC address? Suppose that this IP has this PC1 has this MAC address AP. It has AC or AD. This is a MAC address. Okay. So how they are performing task? Can anyone describe me? Because very main question and no one asked me.
So you mean from the ACL side, from the access list
Not
side,
access, normal thing.
or
Just no,
from the protocol side?
no, just normal thing. Just no, it's the normal topology. Okay.
Yeah.
I
Okay.
said switch uses MAC address table, right?
Yeah.
Switch is a database of MAC address table. Just I have MAC address table AB, AC, and DT. Switch has this MAC address table. Okay.
Okay.
So how switch will know this MAC address has that IP? Because switch doesn't know IP address. This is a layer 2 switch. It will work only MAC address basis.
Is
So
it
how
because
it's converting MAC
because
to IP, IP to MAC? Suppose that this device has a IP address, this one, okay,
yeah,
192.168.1.1.
Mm-hmm.
But my switch will use only this information. I have one port Z0/0,
Okay.
okay, and there is a PC, and that is the MAC address of this PC. But how switch will get IP address of this PC?
is it not because through the MAC address?
Okay, through the MAC address he will get IP.
Yeah.
He's
But
written
okay,
it. It's gonna be written that once you check it and you see it is for the switch.
okay, let's check.
No, right?
Oh, I'm just asking
Yeah.
how your MAC address is converting in IP address and IP address is converting in MAC address.
Oh, you mean mapping of the host to the IPs and the IP to the host?
Yeah, how it's converting? I'm just asking.
Oh, how it's being converted.
Yeah, how it's converted.
I don't know. I don't know how it's been converted.
Because if I will talk about a little deep, so in layer 2 we have frame. Okay, frame has only source MAC address and destination MAC address.
Mm-hmm.
Destination MAC address. Yeah, that's it. Yeah, there is one more thing. We will ignore that. Preamble. This is the total length of switch. This is a kind of frame which work on layer 2. Source MAC address. What is your source MAC address? What is your destination MAC address? But if my this frame will go in layer 3. So in layer 3, we don't have MAC address, right? It will work there on IP address. It will go on router. So there it will work on IP address. So how this process, how they are converting this MAC address to IP address? There is a R protocol, okay? Address resolution protocol. So it will convert your IP into MAC and MAC to IP. That is the basic use of IR protocol. I will tell you in detail also this thing, but always I forget. Okay. If you will see show arc table command you will use, you can find detail. Your IP and MAC address would be there. So basically this protocol play major role there to convert your IP into MAC and MAC into IP. Okay. So same here, our protocol is running behind your topology. It is converting your IP into MAC and MAC into IP. Okay. Got my point? I will tell you in detail this thing also, but
Okay.
yeah.
'Cause I still don't get how it's going to convert it.
So that is why if you want to check the Ashish, that's why if you want to check the IP address on the Mac, we use show IRP.
Yeah, basically if I want to check show R. So
So
R means I am trying to check what type of information my switch is getting right now. Okay, we can make a little topology regarding to this. Okay, basically we were doing access list, but let's see, because I don't think so access list will complete today. Okay. My God, how many pages? Okay, wait a second. Okay, so basically this I'm just talking about R. Okay, so R types of packet structure. Just ignore this thing because it will go in too much different deep. Sorry, just leave this thing. This is telling you address resolution protocol is a required TCP standard. This is theory. R resolves IP address used by TCP IP based software to media access control by LAN hardware. Okay, too much theory. It's showing you R packet. Do you know packet? Or
Yeah.
you are seeing first time packet? Actually, this is the packet which we say, packet we are sending to router. Packet has lot of information. So our packet has hardware type. What is your hardware type? This kind of messages in ARP. What is your hardware type? What is your protocol type? Your hardware length, protocol length, operation, sender hardware address, sender protocol address, target hardware address, target protocol address. Okay, they explain too much deep in the. Okay, so this scenario, so see this scenario. So one, see one. our cache is checked. By the way, what's happening there? Can you try to understand? This host B communicating to host C. Okay, host B is communicating to host C. So host A IP address is 10.0.1 and host B IP address is 10.0.2. I have pen or not? Yeah. So this is host A and this is host B. So host means PC. We use for PC host or any system. So first what is going on here? Our cache is checked. Means our table is checked. The second thing, this our request is sent. The third thing, our entry is added. Okay, they made very difficult this thing. Where is my pen? Okay, lost my pen again. Great. So, uh, so basically in this topology, it's showing communication between host B to host A. So it is step by step. What will happen? First, our cache will check. Then other step, what will be the other step? Just leave it. Our request will set. Then third step, our entry will add. Then fourth step, our reply will send. And that five step, our entry is added. So basically, this thing I will make you easy for you. Okay, just let me check my pen. Is it? It was here, I think. Oh my god. Give me just a second, okay? Okay, got that, yeah. Okay. Basically, you have two devices. This is I am saying host A, and this is I am saying host B. Same topology I am using. So this is the IP address of this device 10.0.0.1. You can take any IP address. And this is the IP address of this device. And this is the MAC address AB, and this is PC. This is MAC address. Just writing in short way. Because full if I will write, so my whole day will go here. MAC address. So basically, what they are saying for ARP, first it will check ARP table. First step, this device will check ARP table. Then second step, it will send a ARP request. But there is a question. Why ARP request is sending there? Why ARP request is sending there? Just miss one thing. Suppose that I don't have, you should have, one thing miss in this kind of thing. I have this IP address. Okay. This is MAC. Why I deleted? Oh my god. Okay. I should delete this thing. I deleted other thing. Every device has ARP table, right? Every device has ARP table. So this device has a ARP table. Like my IP address is 10.0.0.1 and my MAC address is AB. This is a ARP table. Okay. Every device has ARP table. This device also has a ARP table. 10.0.0.2 and MAC address is PC. Okay. It is clear? Any problem here? Every device has a ARP table. Just simple thing. What is the ARP? Combination of IP and MAC, right?
And this, yeah.
It is clear.
Yep.
But
Yeah.
this PC wants to communicate this PC. So
Yes.
this PC need information, right? So this PC know only I have MAC address of host B. I want to know the IP address of host B. This one. Host A wants, I want to know about IP address of host B, but I have only MAC address. So first it will check in the ARP table. First step, it will check in the ARP table. So he will see, okay, I have MAC address of that PC, but IP is not there. IP I don't have. So what I can do? So it will send a request, ARP request. He will say, I have MAC address, but I don't have IP address. Can you tell me IP address?
Mm.
Okay. And
Good.
this PC, okay. But in ARP request, in this process, it will add host A, IP address, and MAC address both. So PC, this host B will see, okay, I get a IP address 10.0.0.1 and this is the MAC address AB. So first it will add in ARP table 10.0.0.1 and MAC address is AB. So second step, what is the host B added information of added information of host B, not A, host A. So what host B did, this information, host A IP address, host A MAC address added in ARP table. What happened? Again, I am telling you this scenario. This host A has only this host A
Mhm.
this host A only has, oh my god, my dog is disturbing too much. Wait. Okay. So what was information here? Host A has only MAC address of host B. Okay. Host A wants to know what is the IP address of host B. So host A sent a request to host B. I have your MAC address. I want to know about your IP address. In this message ARP request, host A sent his IP address at MAC address. Host B get a request. Okay, I got a request. Someone wants to know my IP address. and this is the information of that device. Okay, so he added in the ARP table. Then he got, okay, it is for me. So host will be sent a reply. This is my IP address and this is my MAC address. You can add. Then host A got, okay, the IP address of this one. So it's added in the ARP table.
Mm.
So that like this, ARP work. Just one thing, if you have missing, suppose that you don't have IP address or you don't have MAC address, you will send to your neighbor. It is automatic process. You will not do anything from your side. Did you get this thing or not? Let me know. Otherwise, tomorrow again I will explain you better way.
It's a little bit still confusing, anyway.
Yeah, little bit confusing. So
Yes, but
just
we still get it.
yeah, just try to
It's
remember.
always like that. Yeah,
Okay,
yeah,
this PC doesn't have MAC address. Okay,
yeah.
MAC address of what? Destination. And destination you have this PC. And this is BC is MAC address. This is AB. So he will send a request. Can you send to me?
Send.
Yeah, ARP request. He will send a request. PC1 and PC2. Can you send me MAC address of your? So it will reply. You can take my MAC address and they will make a ARP table. That's it. Okay.
Yeah,
It should be good.
yeah.
It is good. Just they will make
It's
a
good.
just they will make a table of
Okay.
IP address and MAC address.
Okay.
Both PC will make a table
Yeah.
IP address plus MAC address.
MAC address. Okay.
If one thing is missing, so they will communicate to each other to get to find this thing.
To find the missing thing
Ah,
from each
yeah,
other.
to find the missing thing. That
Yeah.
is that is ARP basically.
Okay.
Yeah, it's
That is the
very
basis of what's.
yeah
So the communication between the two of them is, do you have these? Do you have that?
yeah
Right?
right.
Okay. So they exchange it back.
Yeah, they are exchanging
Okay. Okay.
because they need every information. What I said, if PC1, suppose that this is the MAC address of PC1,
Okay.
okay, and this
Yeah.
is the IP. Oh, again, this is the IP. So I have two information. I already have a table of this two information, right?
Yeah.
And AB is my MAC address. Same PC1, PC2, sorry. This is the BC MAC address
Mhm.
and IP is 192.168.1.2.
Mm.
So this is also table PC2 has 192.168.1.2 PC. So suppose that PC1 has only MAC address of PC2. Okay,
Two.
just MAC address in this table.
Mhm.
He wants to know about IP address. Can you tell me the IP address of what is your IP address? So when he's sending this thing, okay,
Yeah.
he's sending this request. In this time, he will send
With
his
his
info,
IP address.
information also.
That's true.
This is my MAC address and this is my IP address.
You send him with your IP address.
Yeah, and I
That's
ask him, could you tell me your IP address? So
mm,
this PC2 will add this information also. Okay, 192.168.1.1 and MAC
that,
address is AB. He wants to know about my IP address.
mm.
So he will send a reply. This is my IP address.
MAC address and my MAC address.
Yeah, and MAC address. So MAC address we already have. So we will add it will add IP address here. That's it.
That's it.
Yeah.
Okay.
Only missing information they will share with each other.
Sure that.
Yeah. Okay. So
Makes sense.
that is ARP, address
Okay.
resolution protocol.
Okay.
That's why I always say convert in MAC to IP, convert IP into MAC.
Mm.
Okay, so see you tomorrow, guys. I think it's too much for today.
All
I
right.
will
Thank
complete,
you.
yeah, tomorrow this access list.